This is the second video on the scalar product. Let's start with some properties. Firstly, the dot product between the vectors A and B is the same as the dot product between vector B and A. So the order doesn't matter. That makes sense because if you think about the process of finding the dot product, multiplication is commutative, doesn't matter about what order you do it in, so that's why that property exists. Second, the dot product of A and vectors B plus C is the same as the dot product of A and B plus the dot product of A and C. So it's kind of like multiplying across like you would with brackets. Probably easier if you ever had to do this, work out B plus C first, add those two vectors, then find the dot product. Now the scalar multiple of A dot B is the same as a scalar multiple of A dot B, or A dot the scalar multiple of AB. Again, you're probably better off going for this option if you have a choice. I should highlight the previous one as well. The dot product of A and 0 is 0, and the dot product of two of the same vectors is the magnitude of that vector squared. And again, if you think about the process of what you're doing, that makes sense. Now our formula for dot product can also be rearranged to find the angle between the two vectors. So remembering that dot product is if you have two vectors A and B, that angle in the formula is the theta, is the angle between the two vectors. So our general formula is the dot product between vector A and B is the magnitude of vector A times the magnitude of vector B times cos of theta. We can rearrange to get cos theta on its own. So if we had all the information and we wanted to find the angle instead, we would divide both sides by the product of the magnitude of the two vectors. So that gives us cos theta equals the dot product over the product of the magnitudes. Now also remember that to find the dot product, we can multiply and then add the corresponding components. So you can see that's where this formula is coming from. So let's do an example. We've got two vectors A and B. Calculate the angle between them to the nearest degree. So let's write our formula. Now we have the vectors in component form. So we're going to use this version of the formula. So that's going to be 4 times by 2 plus 3 times by negative 3. So just looking at those corresponding coefficients all over. Now the magnitude of A I don't have, so I need to work that out. That's a square root of x squared plus y squared, so 4 squared plus 3 squared. You might realize this is a 3, 4, 5 triangle as I just have as I'm working it out. So it's 5. Could have just done that straight off. Magnitude of vector B, square root of 2 squared plus negative 3 all squared. So 4 plus 9 is a square root of 13. So we have 5 root 13. Now at the top we have 8 take 9, so that's a negative 1. We need to rationalize our denominator. Actually, there's no need to rationalise a denominator because we're finding theta. So don't do that. So you can go straight to your calculator. So theta is going to equal inverse cos of -1 over 5 root 13. And that is approximately 93.18 degrees. Finish with a therefore statement. So the angle between the two vectors is approximately 93 degrees. Note I went to the nearest degree because that's what the question asked.